All right, here is a question that if you did the last lab, you pretty much know the answer to it. Where does SQL store all of its objects and data? Data files. We know this. Well, SQL uses tables and other objects like views and stored procedures and functions. Most of the time those just work on other tables. And it stores all of them in a data file or data files. In the last example, we had a main data file, and all the objects and all the data of those objects went inside of there. Now, every MDF file must have a storage location. In the example you see here, it was the C drive's SQL folder, and the name of the main data file was jproco.mdf. Okay, so if the SQL server needs some data back to recall it, it looks at the main data file to get all of its objects and its data. Okay, so when you create a database, you know you have to have at least one data file. Now, it's a good idea to make sure that data file is large enough even when the database starts out empty. It's kind of like the grand opening of a mall. Why is the parking lot so big if nobody's ever shopped there? Well, they're anticipating being able to handle all of the flow and all of the traffic when it does come. And they don't want to have to remodel and react and grow the parking lot just because customers finally came in. The database is empty, and you know it's going to take up 5 gigs. Why don't you make a 5 gig MDF in anticipation? So it's a good idea to make a data file large enough to hold your expected data. Now, how big can you make it? Well, it depends on how big your hard drive is. That's your limit. So what are you going to do if your data file runs out of space? Now, sometimes that's not a problem. You have a 100 gigabyte drive, 30 gigabyte data file, 70 gigabytes free. You can elect to grow the MDF to use the unused space on the drive. Okay, so what about if your drive runs out of space? Well, you're going to need a bigger drive or you're going to need another drive. How about if business is going so quickly that your activity overwhelms the throughput of one drive? So for these problems, there's a number of well-known and tested solutions. Solution number 1. Well, this solution number 1 comes from the problem of your data file just wasn't big enough. Well, there's data file properties, like the size. A larger size data file can hold more tables or data in those tables. And you can also set the file growth. So if your data file fills up, you know SQL Server can't run anymore unless the data file is allowed to grow. You can specify at what rate it will grow. Okay, a 30 gigabyte data file fills up. Do you want it to go to 31 or do you want it to go to 40? How much incremental growth do you want every time it fills up? That is known as file growth. All right, where do you put it? The C drive is kind of a busy beast. It's got the operating systems, it's got several services running on it, it's got lots of different calls. So you might want to take the throughput of the C drive and leave it for its normal day-to-day operations and place your data file on its own dedicated drive. Maybe you've got a D drive slated just for your data. Now, solution number 3 is about where to place it. Let's say you've done this. D drive has your MDF, and it's just not big enough, or it's just not fast enough. You can create, in addition to your main data file, a secondary data file, and split where the storage takes place. Now, let's say you figured out that your production tables take up about 50% of the load, and all the other tables combined take up the other 50%. You can elect to have the production tables go in your secondary data file, and all other tables, reporting tables, lookup tables, they can go in the D drive on the main data file. Now, how about multiple data files for automatic load balancing? Now, that's great if you got a bunch of tables and you split them up, but what if 99% of your activity is in this one giant transaction table? And that table would overwhelm the throughput of any given drive you have. How can you take one giant table and split it across many data files? Well, the reality is you can only assign a table or any object to one file group. Fortunately, you can associate a file group with as many data files as you need. So that's what we're getting ready to talk about. Okay, file groups have many advantages. Let's say the 4 data files you see on the left, the D through the G drive, were for production, and you wanted to change all of the properties at once. You'll have a file group 1, and you can manage all of those files in that file group at one time. And we'll put these other data files in file group 2. Now we learned a little about log files. Data files have an MDF and NDF extension, and they contain all of your data objects and all of the information for use by the SQL Server. Now, what if you wanted to know what data was changed an hour ago? Well, your log file has been logging all the changes and all the data that's been coming in. So SQL keeps a history of its recent changes in an LDF or log data file. When you completed Lab 1.1, you created one data file called radisco.mdf, and that was in the SQL folder of the C drive. Now, since we didn't specify any file groups, it threw it in the primary file group for us. We also created a log file in the C:/SQL folder in the radisco_log.ldf file. Now, that was not part of a file group because logs do not participate in file groups. The goals of the upcoming demonstration are to do this: have a primary file group with one main data file, create a user-defined file group called orderHist that has 2 secondary data files. The D drive SQL folder will have 2 different files, radisco orderhist1 secondary file and radisco orderhist2 secondary file. Finally, on the E drive, we will use the SQL folder and put radisco_log.ldf. Now, it's likely that the machine you're practicing on does not have a C, a D, and an E drive, and to improvise, what we're going to do is we're going to have a C_SQL folder and pretend that's the C drive, a D_SQL folder and pretend that's the D drive, and an E_SQL folder and pretend that that is the E drive, just to get us used to specifically placing files where they go upon database creation. The Radisco database has been dropped. It's not on the server. And a create database Radisco statement has been started. Now, you're familiar with the on keyword. The on specifies what you're going to have in your primary file group. And we usually put our MDF in there. Now, the next line represents a user-defined file group, and we have to give it a name. Since our plan is to put 2 NDF files, I have 2 sets of parentheses after the file group, 1 for each file. Finally, our log will go in the final set there. Now, let's go ahead and set the name and the file name for all of our MDF, NDF, and LDF files. Now let's make sure our file system is ready. We're going to put the MDF in the C_SQL folder, the NDF in the D_SQL folder, and the LDFs in the E_SQL folder. Let's do that. Let's say name is equal to, and we'll call it radisco_data1. And we'll put a comma, and we'll say file name equals single quote C:/SQL /radisco_data1.mdf. Okay, that was easy to type, and I'll take care of the C_SQL at the end. Let's do these 2 in the user-defined file group. Let's say name equals radisco_history, or we'll just say hist1, comma, file name equals C:/SQL radisco_hist1.ndf. And let's put the other NDF in here and call it radisco_hist2. And the file name will be equal to c:\/SQL/radisco_hist2.ndf. And finally, let's get our log. And let's space this out so we can see clearly where everything is. This on has our primary, our secondary is in the order hist file group, and lastly our log. And the name of Radisco log will be put here, comma, and then the file name will be c:/e_sequel /radisco_log.ldf. And that brings me to what I said earlier. This will be the D drive with D underscore, and this will be the C drive with C underscore. Let's go ahead and run this. Pretty good sign, no errors so far. Let's check the C_sequel. That has the MDF. The D has the two NDFs, and the E, well, that's got the LDF. Here's a graphical representation of what we've just achieved. We put the MDF file in the primary file group, and we put the two NDFs in their own user-defined file group called order history, and on the E drive, we've got the log file. Let's check Management Studio and see what it says. Let's find our Radisco database and then get its properties. First of all, let's click on File Groups, and notice we have a primary file group with one file in it, and an order hist file group with two files in it. Well, which files exactly does it have? Let's click on the Files page. Here is the Data 1 in the primary file group, Order Hist 1 in the Order Hist file group, Order Hist 2 in the Order Hist group, and you can see the location is C for the main. These two are on the D, and the log, it's on the E. Lab 1.2, Skill Check 1. Drop the Radisco database and recreate it with the data files and file groups shown on the previous page. When complete, your database properties dialog, file groups page, and files page should resemble the screenshots below. Skill Check 2. Create the practice database growth co using the name, size, file growth, and location specifications below. After creating this database, confirm your results match the database properties dialog box seen here. Skill Check 3. There will be times when you don't want your database to grow automatically. You want SQL Server to notify you when the MDF or log file is full, so you can manage the upsizing process yourself. Create the database no growth using the name, size, file growth, and location specifications below. After creating the no growth database, confirm the result matches the database properties dialog box seen here.